Alright, so we just took the complicated circuit, broke it down from all these resistors in series, these resistors in parallel, and simplified it down to here. Then we had basically some more resistors in series, simplified that down to these three in parallel, simplified that all the way down to one lowly 5 ohm resistor in series with that 120 volt battery. So now we're going to go backwards. We're going to start figuring out the currents and the voltages for each of these resistors, reconstructing the original circuit. So let's start with the most basic. We might have questions that say, hey, what's the current through the battery? You'd have to simplify it all the way down until you get one resistor, one voltage. And then for any current, voltage over resistance. That's how we're going to find it. So 120 volts over 5 ohms, that's going to give us 24 amps. So we know there's 24 amps going through the battery and through our equivalent resistor right there. Alright, let's back this up. So that's what's going through the battery. Here we have combinations ABC, this is resistors K and L. All these are combinations, but we know it's all in parallel. So each one is going to have 120 volts across the entire thing. Let's see, I'm going to try to do voltage in black here. 120 volts, 120 volts, 120 volts, right? So if we know the voltage across each one, and we know the voltage across each one, and we know the resistance through each one, resistance of each one, we can calculate the current here. So anytime we're calculating current, again, voltage over resistance. So 120 volts, 15 ohms. We calculate over here, 120 divided by 15, we get 8 amps. So right through here, 8 amps. And since this is basically the same for each case here, each branch is 8 amps, this branch is 8 amps. So each is going to be 8 amps. Alright, so we know the voltages, we know the currents through all of these. Backing up one more step. We knew this is the same thing here, 8 amps was going through here. We know this is a series combination, so there's only one place for the current to go. What was 8 amps going through this middle branch, we have 8 amps going through each of these resistors that we took to make that equivalent resistance. So 8 amps, 8 amps, 8 amps, and again on here still is 8 amps. Now, there's 120 volts across the whole middle branch here. What we need to figure out is how is that divided across each of these three resistors? Well, we have the resistance, we have the current, so voltage is equal to IR in any case that we do. So current's 8 amps, resistance here is 4 ohms, 8 times 4, 32 volts across that 4 ohm resistor. But that was, remember, in combination of the parallel combination that was already there. Across this 8 ohm resistor here, so 8 would be 8 times 8 amps, or 64 volts. And we have 3 times 8 amps, or 24 volts. Now all of that should add up to the 120 that the battery is providing us here. Let's see, 32, 64, 24, and it does, thankfully. So now that we have all of those, and again this is still 120 from the last one, now we can step back to all the way to our original circuit. That tells us that through that bottom branch here, just like we figured out through the bottom here, there is 8 amps going through here, which means there has to be 8 amps going through here. Same thing with these. We'll split this up. There's 8 amps going through each and every single one of these. 8 amps, 8 amps, 8 amps. We're going to find the voltage the same way. V equals IR. 8 amps times 5 ohms, 40 volts. All these are the same. 40 volts, 40 volts. Alright, so back here we already found out the information for the G resistor. This is 64 volts, and there was, again, 8 amps going through here. But let's look at the parallel combinations we have, because we have 8 amps coming out, and we have 8 amps coming in, but it splits here. Remember, current splits in parallel, so each of these is going to get a different current, and we're not sure what that is yet. One thing we do know about it, one thing we figured out here, is that the voltage across the whole thing is 32 volts. So from this point to this point, this entire voltage across here is, what did I say, 32 volts. So which means these are all in parallel. Anything in parallel has the same voltage. So it's 32 volts across the 20 ohm, across the 10 ohm, across the 10 ohm. So we need to find current. Like anything we do, current is voltage over resistance. 32 volts over 20 is going to give us 1.6 amps here. Amps I'm doing in blue. I'm going to stay consistent. 1.6 amps. 32 volts over 10 ohms will give us 3.2 amps. And again, 10 ohm, 3.2 amps down here. Now these should add up to the 8 amps we started with. Let's see, 3.2, 3.2, 6.4, 7, and 9.6. That does add up to 8 amps. That works. So now we have the voltage and current for each of these resistors. We're going to do the same thing to HI and J. Let's see, the voltage we found across that whole combination was 24 volts. So we'll put that all the way across here. That's 24 volts for each of these, HI and J. And so the current is going to be, like always, V over R, or 24 volts over, let's start with the 15 ohms. Let's see, 24 over 15. It's 1.6 amps. 24 over 15, same one, 1.6 amps. And 24 over 5 is 4.8. Now here's a good place to double check. The branch with the least resistance also has the most current. And that should make sense. If it's easier to do, more electrons are going to do it. So least resistance, most current. And I believe that is the last, oh, nope, forgot K and L. Right down here. But just like we did before, we have a current through it, we have a resistance. So now I'm finding a voltage. 8 amps, 10 ohms, voltage is 80 volts across this, it should be 80 volts. Same thing here, 8 amps, 5 ohms should be, voltage here is 40 volts. And now from this diagram you can fill in the table here for all the values to keep track of everything. But that is the overall picture. Simplify the entire circuit and then just start working backwards, voltages and currents, each time for each place until you find eventually the final answer.